Hi everyone, welcome to the My Life is Math Learn channel. Today we will discuss about complex numbers. The general form of a complex numbers x plus iy, where x is real, y is imaginary. Example: 2 plus 3i. 2 is real, 3 is imaginary. Here I is the imaginary part. I is equal to square root of minus 1. I square is equal to minus 1 square root of minus 1 whole square, that is equal to minus 1. I cube is equal to I square into I, that is equal to I square into means minus 1 into I minus I. I power 4 is equal to I square whole square minus 1 whole square, that is equal to 1. This sequence will continue to until infinity. Let's check the one example problem. I power 1728, that is equal to I power 4 into 432, that is equal to I power 4 means 1 power 432, that is equal to 1. Now I power 1727, we can write as a I power 1727 I power 1724 into I cube. We will get I power 4 into 431 into I cube means minus I. 1 into I power 4 1 into minus I, that is equal to minus I. Let's do the question. Z is equal to 1 by 4 minus 3i. Real part of Z is equal to what is the value? Imaginary part of Z is equal to what is the value? Given that 1 by 4 minus 3i, we can rationalize. After rationalize, 1 by 4 minus 3i into 4 plus 3i by 4 plus 3i. 1 into 4 plus 3i, that is equal to 4 plus 3i by a square minus b square formula here. 4 square minus 3i whole square. 4 plus 3i by 4 square 16 and 3 square 9, I square minus 1. We can apply next. That is equal to 4 plus 3i by 16 plus minus of minus 1 plus 9. That is equal to 4 plus 3i by 25. That is equal to 4 by 25 plus 3 by 25i. The real part of Z 4 by 25. Imaginary part of Z 3 by 25. Points to remember. Here mainly most important points here. If if A comma B belongs to R, then Z plus A plus IB is a complex number. But if Z is equal to A plus IB is a complex number, then it is not a necessary A comma B belongs to R. Example: Z is equal to 2 plus 3i plus 2 plus 4i into I. It is a complex number, but not in the form of a 2 plus 3i not a real number, 2 plus 4i is not a real number. Sometimes complex number also possible. So here A and B both are not a real numbers. If imaginary part of complex numbers is 0, then Z is known as a purely real. Example: 4 plus I into 0, that is equal to 4. 4 is a real. Next, if real part of a complex number is 0, then Z is known as a purely imaginary. Example: 0 plus 4i, that is equal to 4i. 4i is a imaginary part. Z is equal to A plus IB or A plus IB, capital A plus IB. If B not equal to 0, then Z is a imaginary number. A complex number, know which is imaginary, B not equal to 0, is non-comparable. And it cannot be compared with other numbers after imaginary number. Fifth point. In an organ plane, the complex number is a point where organ plane is nothing but coordinate axis. Organ plane means it is one of the coordinate axis, but it is represented by imaginary numbers. Here x-axis is a real part, y-axis is a imaginary part. So xy plane we can call as a organ plane. And every point on the organ plane it is a complex number. And the distance from origin to point is a mod of z. Mod of z. The distance between the origin and point z in the organ plane is called magnitude or modulus of z. So mod z is equal to square root of x square plus y square. There is equal to square root of real part of z whole square plus imaginary part of z whole square. Argument of z. The angle made by the line segment with the positive direction of x-axis is anti-clockwise is known as a argument of z. Theta is equal to tan inverse of y by x. So tan inverse of y means imaginary of z and x means real part of z. So general argument. There are three types of arguments there. General argument, first one. Argument z is equal to theta plus 2n pi because n is belongs to I. Because if you take first round theta, that is a theta. If you go full round complete option, again reach the theta angle, it is a theta plus 2 pi. And it is repeated infinite times. So the general form is theta plus 2n phi. The principal argument we can represent as a amplitude of z. The theta always lie between the minus pi to pi. We can fix the theta always minus pi to pi. What is the graph? If the theta is first quadrant, the tan inverse of mod y by mod x, it is no problem. But theta is second quadrant, we can take as a pi minus theta. Theta is third quadrant, minus pi plus theta. Theta is fourth quadrant, minus theta. Lead positive argument. Arg z is equal to theta. Theta is belongs to 0 to closed interval 0 to 2 pi. So here first quadrant positive and third quadrant positive and second quadrant, fourth quadrant are negative. So we can consider as a lead positive 0 to 2 pi. It's enough. Arc z behaves like a log, which principal argument of arc z does not behave like a log. But principal argument does not behave like a log. Only arc z behaves like a log. Let's solve the one question. Z is equal to minus 3 root 3 I. So arc z is equal to tan inverse of minus 3 root 3 by minus 3. There is equal to tan inverse of root 3. There is equal to pi by 3. So don't take the direct value pi by 3. Look, minus 3 root 3, it is the third quadrant. So the angle made by third quadrant pi by 3 with x-axis. So here full general argument is here pi plus pi by 3 means 4 pi by 3 plus 2n pi. and lead positive is 4 pi by 3. And the amplitude of Z is equal to, already I told you in the third quadrant, minus pi plus theta. There is equal to minus pi plus theta means minus pi plus pi by 3. There is equal to minus 2 pi by 3. Question number 4. Find the argument Z. Z is equal to 1 plus I whole power 7, root 3 plus I whole power 9, 1 plus root 3I whole power 5. Arg Z behaves like a log. Previous already I told you. So arg Z is equal to argument of 1 plus I whole power 7 into root 3 plus I whole power 9 by 1 plus root 3 I whole power 5. We can split as a logarithm, log x by formula and by log x by y formula. At a time we can use arg. After using logarithm formula, arg of 1 plus I whole power 7 plus arg of root 3 plus I whole power 9 minus, in the denominator we can take, so minus 1 plus root 3I whole power 5, argument of 1 plus root 3I whole power 5. So logarithm property, after satisfying the power value coming front, 7 arg 1 plus I, 9 arg root 3 plus I minus 5 arg 1 plus root 3I. So here argument means tan inverse of imaginary part by real part, means tan inverse of 1 by 1 plus 9 into tan inverse of imaginary part 1 by root 3 minus 5 into tan inverse of root 3 by 1. There is equal to tan inverse 1 means 45. So 7 pi by 4. Tan inverse 1 by root 3 is a 30. So 9 pi by 6 plus minus 5 into tan inverse root 3 60. So 5 pi by 3. There is equal, after taking LCM, the LCM is 12. 21 plus 5 plus 18 pi minus 20 pi, there is equal to 19 pi by 12. Arg Z behave like a log. So arg Z power n is equal to n of arg Z. Arg Z1 into Z2 is equal to arg Z1 plus arg Z2. Arg Z1 by Z2 is equal to arg Z1 minus arg Z2. Very most important. Thank you. Please subscribe our channel for creating more videos.